Welcome to Lesson 9 of Week 11, focusing on agency culture comparing the National Institutes of Health, or NIH, and the National Science Foundation, or NSF. This lesson examines how these two major federal research funders differ in their cultures, priorities, and procedures, and how to adapt your proposals accordingly. NIH and NSF are the two largest federal funders of basic research, together providing billions of dollars annually for scientific investigation. However, they operate with distinctly different cultures, evaluation criteria, and administrative procedures. A proposal strategy that works well at one agency may be poorly suited for the other. Understanding these differences enables you to craft proposals tailored to each agency's expectations. NIH focuses on biomedical and health research, with an emphasis on understanding, preventing, and treating disease. NSF supports fundamental research across all scientific fields, with emphasis on advancing knowledge and broader societal impacts. These different missions shape what each agency values and how they evaluate proposals. By the end of this lesson, you will understand the cultural differences between NIH and NSF. You will learn how their evaluation criteria differ. You will recognize distinctive procedures like NIH's just-in-time requirements. You will develop skills for adapting proposals to each agency's expectations. Note that agency priorities and procedures may shift. Verify current requirements in specific NOFOs. This lesson has 4 primary learning objectives. First, you will understand the distinct missions and cultures of NIH and NSF. Their different purposes shape different expectations for proposals. Recognizing these cultural foundations helps you appreciate why the agencies operate differently. Second, you will compare evaluation criteria and what each agency prioritizes. NIH uses significance, innovation, approach, investigators, and environment. NSF uses intellectual merit and broader impacts. These different frameworks require different emphasis in your proposals. Third, you will recognize procedural differences, including NIH's just-in-time requirements that request certain documentation only after favorable review. These procedural differences affect how you prepare and what you submit initially versus later. Fourth, you will develop skills for adapting proposal strategies to match each agency's expectations. The same research project might be proposed differently to NIH versus NSF. Learning to adapt your presentation increases your competitiveness at each agency. Understanding NIH mission and culture helps you frame proposals appropriately. The NIH mission is to seek fundamental knowledge about living systems and apply that knowledge to enhance health, lengthen life, and reduce illness and disability. Every NIH-funded project should connect to this health-focused mission. Health focus means research must connect to health outcomes. Even when basic science is involved, purely curiosity-driven research without health connections fits less well at NIH than research with clear health implications. Frame your work in terms of how it relates to health. Disease orientation reflects NIH's structure around disease categories and organ systems. The various NIH institutes focus on specific health areas: cancer, heart disease, mental health, infectious disease, and others. Understanding which institute's priorities align with your work helps you target appropriately. Clinical relevance and ultimate translation to patient benefit are valued highly. NIH wants to know how basic research will eventually improve clinical care. The pathway from discovery to treatment matters. Research closer to clinical application or with clearer translational potential often resonates strongly. Understanding NSF mission and culture helps you frame proposals appropriately. The NSF mission is to promote the progress of science, advance national health, prosperity and welfare, and secure national defense. NSF supports fundamental scientific research across all non-medical fields. Basic science and fundamental discovery are valued for their own sake at NSF. Research does not need to have immediate practical application to be valued. Advancing fundamental understanding of natural phenomena is a worthy goal in itself. Curiosity-driven research fits well at NSF. Field breadth is remarkable at NSF, which supports research across physics, chemistry, biology, geology, astronomy, computer science, mathematics, engineering, social sciences, and more. If your research is scientific but not health-focused, NSF may be your primary federal option. Broader impacts represent a distinctive NSF emphasis. Beyond the scientific merit of research, NSF evaluates how the work benefits society through education, broadening participation, practical applications, or other societal contributions. This dual emphasis on intellectual merit and broader impacts is uniquely NSF. NIH review criteria provide a framework for proposal evaluation. Significance asks whether the project addresses an important problem. Will scientific knowledge, technical capability, or clinical practice be advanced? What impact will success have on the field or on health outcomes? Innovation asks whether the project employs novel approaches or challenges existing paradigms. Does it develop new methodologies, challenge current models, or address problems in new ways? NIH values innovation explicitly as a scored criterion. Approach asks whether the methodology is rigorous, well-reasoned, and feasible. Are the methods appropriate? Is the timeline realistic? Have potential problems been considered? Approach often carries the most weight in NIH review. Investigators asks whether the research team has appropriate training, expertise, and track record. Do their qualifications match the proposed work? Have they published in relevant areas? Do they have necessary technical expertise? Environment asks whether the institutional setting contributes to success. Are necessary facilities available? Is there institutional support? Does the environment enable the proposed research? NSF review criteria use a distinctive two-criterion framework. Intellectual merit evaluates the potential to advance knowledge and understanding within and across fields. Is the research question important? Is the approach sound? Will the work generate new knowledge? Does it have transformative potential? Broader impacts evaluate the potential to benefit society and contribute to desired societal outcomes. How will the work benefit education? Will it broaden participation of underrepresented groups? What practical applications might result? How will findings be disseminated? The two-criterion system requires competitive proposals to address both dimensions effectively. Excellent intellectual merit with weak broader impacts is incomplete. Strong broader impacts with questionable scientific merit is also problematic. Both criteria matter. Integration valued means work that naturally integrates both criteria is strongest. Research that advances knowledge while also training students, engaging communities, or producing practical benefits presents a unified narrative stronger than work where broader impacts feel tacked on. Comparing the criteria reveals important differences in how the agencies evaluate proposals. Separate versus integrated structures differ significantly. NIH uses 5 separate scored criteria, each evaluated independently. NSF uses 2 broader dimensions that encompass multiple considerations. The NIH structure encourages explicit attention to each criterion. The NSF structure requires integration. Innovation emphasis differs in explicitness. NIH evaluates innovation as a separate scored criterion, signaling its importance. NSF includes innovative elements within intellectual merit assessment but does not score innovation separately. Both agencies value novelty, but NIH makes it more explicit. Broader impacts are unique to NSF, requiring attention to societal benefits beyond the science. NIH has no direct equivalent criterion. Proposals to NSF must address broader impacts explicitly. Proposals to NIH need not do so unless the specific program requires it. Health framing is required at NIH, where research must connect to the health mission. NSF does not require health relevance. Research is valued for advancing scientific understanding regardless of health connections. This difference fundamentally shapes what research fits where. NIH just-in-time procedures represent a distinctive administrative approach. The concept is that some documentation is requested only after peer review produces favorable scores. Rather than requiring everything up front, NIH delays certain requests until they know an application is competitive. Triggered by scores that indicate funding likelihood, JIT requests signal that your application is being seriously considered. If your score is unlikely to result in funding, you will not receive a JIT request. The request itself is good news about your competitive position. Typical JIT requests include other support documentation showing all current and pending funding for key personnel, IRB or IACUC approval documentation for human or animal subjects research, and budget verification to confirm proposed costs. These items are collected after review rather than with initial submission. The benefit is reduced burden for applications that will not be funded. Applicants whose proposals are not competitive do not need to compile JIT documentation. This efficiency is appreciated, but also means you must be prepared to respond quickly when JIT requests arrive. NSF procedural differences contrast with NIH's just-in-time approach. Upfront documentation means most materials are required with the initial submission at NSF. Rather than delaying documentation until after review, NSF collects comprehensive information from all applicants initially. This front-loads the documentation burden. Facilities and equipment descriptions are included in your initial proposal at NSF. The Facilities, Equipment, and Other Resources section describes what institutional resources support the proposed work. This information is part of reviewer evaluation, not collected later. Project Summary at NSF is a one-page document with specific structure. It must include an overview, a statement of intellectual merit, and a statement of broader impacts. This structure ensures both review criteria are addressed explicitly in the summary reviewers see first. Data Management Plan is a required supplementary document at NSF. You must describe how data from your project will be managed and shared. This requirement reflects NSF's emphasis on research transparency and data accessibility. Writing for NIH requires attention to what this agency values. Health connections should frame your research in terms of health relevance. Even basic science should indicate how understanding the mechanisms ultimately relates to health. What disease or health condition does this connect to? How does this knowledge serve the health mission? Clinical translation should indicate the pathway from your research to eventual patient benefit. You need not promise immediate clinical application, but you should articulate how basic discoveries could eventually improve clinical care. The translational vision matters. Innovation explicit means addressing the innovation criterion directly and prominently. Do not assume reviewers will see the novelty, state it clearly. What is new about your approach? How does it challenge or advance current paradigms? Specific aims represent where NIH proposals live or die. The one-page specific aims document is critically important. It must grab reviewer attention, establish significance, convey innovation, and preview your approach. Many reviewers form initial impressions from the specific aims alone. Writing for NSF requires attention to what this agency values. Pure science is welcome at NSF without need for health connections. Research advancing fundamental understanding is valued for its own sake. You need not justify your science in terms of disease relevance. Scientific importance and rigor are sufficient justification. Broader impacts required means you must address societal benefits explicitly. Do not treat broader impacts as an afterthought. NSF reviewers evaluate this criterion seriously. Weak broader impacts sink otherwise strong proposals. Think carefully about how your work benefits society. Integration strategy weaves broader impacts into the research narrative rather than treating them as a separate add-on. Research that naturally involves students, engages communities, or produces practical applications integrates broader impacts effectively. Forced feeling broader impacts are less compelling. Project summary structure must follow NSF's required three-part format with overview, intellectual merit statement, and broader impact statement. This structure is mandatory. Proposals that do not follow it may be returned without review. Ensure your summary addresses both criteria explicitly. Study section versus panel review represents another difference in how the agencies operate. NIH study sections are standing committees with relatively consistent membership over time. The same group of reviewers meets regularly to evaluate proposals in their area. This continuity means study sections develop institutional memory and consistent standards. NSF panels are often ad hoc, assembled for specific competitions or review cycles. Panel composition may vary more between cycles. This approach allows flexibility in matching reviewer expertise to specific proposal pools, but provides less continuity. Reviewer expertise at both agencies comes from subject matter experts who understand the fields being evaluated. reviewers have relevant technical knowledge to assess whether proposed research is sound and significant. Both agencies strive to match reviewer expertise to proposal content. Discussion format at both agencies involves group discussion of proposals. Reviewers share their assessments, debate strengths and weaknesses, and collectively determine final scores. This discussion allows diverse perspectives to inform outcomes. Common mistakes differ somewhat between agencies based on their different expectations. NIH mistakes include missing health relevance in proposals that do not connect to the health mission, weak innovation claims that do not demonstrate novelty convincingly, and poor specific aims pages that fail to capture reviewer interest. These mistakes reflect failure to address what NIH specifically values. NSF mistakes include inadequate broader impacts that treat this criterion as an afterthought and missing project summary elements that do not follow the required three-part structure. These mistakes reflect failure to address what NSF specifically requires. Both agencies see proposals that do not follow agency-specific format requirements. Page limits, font sizes, margin requirements, and section structures differ between agencies. Using one agency's format for another agency's proposal creates problems. Cross-contamination occurs when applicants use NIH language in NSF proposals, or vice versa. References to clinical translation in NSF proposals or innovation criterion in NSF broader impacts suggest the applicant is not thinking carefully about which agency they are addressing. Choosing between agencies requires understanding where your research best fits. Health research makes NIH the primary option for biomedical and health-related work. If your research directly addresses disease, health conditions, or health outcomes, NIH institutes likely have relevant programs. The health mission alignment is clear. Basic science across non-medical fields makes NSF the natural home. Physics, chemistry, geology, mathematics, computer science, and social sciences outside health fall primarily within NSF's scope. For fundamental research without health connections, NSF is typically your federal option. Overlap areas exist where research could potentially fit either agency. Biological research might fit NIH or NSF, depending on its health relevance. Social and behavioral science might fit either depending on framing. Some investigators submit to both agencies with appropriately tailored proposals. Strategic decisions should consider funding rates, budget size norms, and program fit. Some programs are more competitive than others. Budget expectations differ between agencies and programs. Finding the right program match may matter more than agency choice. Let us summarize the key points from this lesson on agency culture comparing NIH and NSF. NIH and NSF have distinct cultures requiring adapted proposals. NIH focuses on health research with emphasis on clinical relevance and translation. NSF supports basic science across all fields with unique emphasis on broader impacts. Understanding these cultural differences helps you tailor proposals appropriately. Criteria differences show 5 NIH criteria, including explicit innovation criterion, versus 2 encompassing NSF dimensions of intellectual merit and broader impacts. Proposals to each agency should be structured to address their specific evaluation framework. Missing required elements for either agency weakens your proposal. Procedural differences include just-in-time procedures at NIH that request some documentation only after favorable review versus upfront documentation requirements at NSF. Understanding these procedural differences helps you prepare appropriately and avoid surprises. In our next lesson, we will cover agency culture focusing on NEH and arts funders. You will learn how humanities and arts funders differ from the science funders we have discussed, with their emphasis on narrative quality, humanities significance, and audience. Practice exercise. Select a research project and outline how you would frame it differently for NIH versus NSF. What health connections would you emphasize for NIH? What broader impacts would you develop for NSF? How would the emphasis shift between the two proposals?